question 10a, we're asked to solve a quadratic inequality. It's part of a bigger family of inequalities that we've learned to solve, polynomial inequalities. But in any case of any polynomial, we want to get one side equal to 0, which this one already has one side that's equal to a 0. So then we want to use in a quadratic either factoring techniques or use our quadratic formula. This one factors quite readily, so I'm going to factor it into the x squared is x and x. The signs have to be opposite, plus and minus. Factors of 6 that'll give you -5 are -6 and a +1. Now these are my factors, which will tell me exactly where the zeros of the function are. So if I put in a -1 or a +6, we'll get exactly a 0 out as an answer. Now we don't want our answers to be exactly 0, we want them to be greater than 0. So I want to be able to use a couple of concepts that we've learned. Number one, I could use the concept that I have a quadratic equation and it's a positive leading coefficient, so that means the end behavior has to go towards positive infinity, or more simply we know we have a parabolic shape that opens upward or smiles. Everywhere where it's below the yellow line, it is negative, and anywhere my pink line is above the yellow, it is positive. So this is where the parabola is greater than 0. All the outputs are greater than 0 for every output, for every input greater than 6, and our outputs are also positive or greater than 0 anytime we have an input that is less than -1. So any number from a negative infinity to a -1 union with 6 to infinity should give us positive outputs. Now when we have a quadratic equation, that's probably what I would do. I'd graph that parabola, either smiling or frowning. We could also use the interval line test just to show you this is part of that overall larger picture of polynomials. We could put in a number that's to the right of 6, and if I put in a 7 in each location, we'll get a positive number times another positive number, and positive times positive is positive. So I'm just reaffirming that it is going to be positive. In the middle, if I put in a 0, well then I'd have, taking out the 7, put in a 0 and a 0, then I'd have 1 positive, 0 plus 1 is positive, and then I'd have 0 minus 6, the other one would be negative, and positive times negative is negative, so I'm just reaffirming that's negative. And you can do the same interval line test for that one. So you can apply that strategy to all polynomial inequalities. The quadratic, we probably don't have to mess around with the interval line test because we can quickly draw a graph.